Hey y'all. I wanted to make a quick video for you for these last couple of examples in section 2.7 that we didn't get to in class. Um, so just in case that you're having trouble with these, wanted to give you a video to help. All right, so we didn't get to these guys in class. So what if we wanted to find the horizontal asymptotes of something that looks like y equals e to the t divided by 1 minus e to the negative t. Okay, so if we need to find horizontal asymptotes, then what we're going to do is we need to look at the limit as x, or in this case it's t, right, because t is our x coordinate here. We need to look at the limit as t approaches infinity and see if we get a number out. If we do, then we have a horizontal asymptote on the right end of our graph. And we also need to take the limit as x approaches negative infinity of this function to see whether we have a horizontal asymptote on the left side of the graph. And we'll know that we have a horizontal asymptote if that limit as x, or t in this case, goes to negative infinity, gives us a number. And we have to check both sides of the graph because sometimes you only have a horizontal asymptote on one end and not the other. And sometimes you have a different horizontal asymptote on each end of your graph. As long as one side of your graph goes to a horizontal asymptote, it is a horizontal asymptote for your function. And because each end can go to a different number, it is possible that a function can have two horizontal asymptotes. That is a thing that can happen. And you'll see that in a couple of your homework problems. Okay, so in order to check to see if we have horizontal asymptotes, we're going to look at the limit as t approaches infinity of this thing, e to the t over 1 minus e to the t. And we're also going to have to look at the limit as t approaches negative infinity of this thing. Again, you have to check both ends of your graph because sometimes you'll have a horizontal asymptote on one end and not the other. And sometimes you'll have different horizontal asymptotes on each end of your graph. So we're going to check both ends. And now we have to figure out how to evaluate these limits. So if t is approaching infinity. Oh, and sorry, I wrote this wrong. This is a minus t down here. Missed that. Okay, I think I have that copied correctly now. Okay, so if we're looking at the limit as t approaches infinity of this thing, well, on top, e to a number that's getting bigger and bigger and bigger and bigger, if I take 2.718 and I take it to higher and higher and higher powers, I'm going to keep multiplying by 2.718. This thing on top is getting bigger and bigger and bigger. Now on the bottom, I have 1 minus e to the negative t. Negative exponents are hard to understand and deal with, so I'm going to rewrite this and turn that negative exponent into a fraction because that's what negative exponents do, right? So this is going to be 1 minus 1 over e to the t down here because that's what e to the negative t means. It means 1 over e to the t. So we are evaluating this as t goes to infinity. Again, we said that the top is going to blow up to infinity. It keeps getting bigger and bigger and bigger. And now on the bottom, we have 1 minus 1 divided by e to the t. And as t gets bigger and bigger and bigger, e to the t gets bigger and bigger and bigger and bigger, which means 1 divided by bigger and bigger and bigger numbers gets smaller and smaller and smaller, and this thing heads toward 0. So overall, this thing is going to infinity divided by 1, which is infinity. Because the limit as t approaches infinity of my function gives me infinity, that means I have no horizontal asymptote at the right end of the graph. We're at the right end of the graph because t was approaching infinity. T approaches infinity on the right side of the graph. And since this is not a number, it's infinity, that means we don't have a horizontal asymptote. The only way to get an asymptote is to get a number out, as your x coordinate, or in this case t, goes to infinity or negative infinity. Okay, so there's no horizontal asymptote at the right side of the graph, but that doesn't mean that there's not one, period. We have to check the left side of the graph as well. To do that, we're going to take the limit as t approaches negative infinity to see what happens on the left side. And in that case, when we plug that in, we are going to get e to the negative infinity over 1 minus e to the negative infinity. It's kind of weird to plug infinity in because it's an idea, not a number, but we have to figure out what's happening to this. Okay, so if I have e to a giant negative number in the exponent, I have a negative in the exponent. My brain has a hard time with that. I'm going to rewrite that as 1 over e to the positive infinity. That's what that negative exponent means. And then on the bottom, I have 1 minus e to the positive infinity. Okay, so what's happening here? I have 1 over e to the infinity. So as t gets bigger and bigger and bigger, e to the infinity, right? E to larger and larger and larger numbers. This whole denominator becomes bigger and bigger and bigger. 1 divided by bigger and bigger and bigger numbers is headed toward 0. And on the bottom, I have 1 minus e to the infinity. Now, again, e to bigger and bigger and bigger numbers becomes bigger and bigger and bigger. 1 minus bigger and bigger and bigger numbers becomes a huge negative number. So what happens when I take a very small number? Again, this is a limit, so I'm never actually hitting 0. I'm just heading towards 0, and I'm getting very small numbers out here. What happens when I take a very small number and I divide by a huge negative number? If you're not sure, put it in your calculator, test out a few things, like take 0.01 and divide by 1,000 or negative 1,000. See what happens. When you take a small number and you divide it into a lot of pieces, right? If you divide by a big number, that means you're dividing it into a lot of pieces. A small piece to start out with, broken into a lot of pieces, gets smaller and smaller and smaller. This negative on the bottom will make our numbers negative, but a small number divided by a big number heads to 0. This thing is heading toward 0. Again, they're going to be very small negative numbers, but they're going to keep getting smaller and smaller and smaller and smaller and smaller and heading towards 0. Again, to see that, test it in your calculator, right? 0.01 divided by negative 1,000. It's going to be tiny, tiny, tiny negative number, close to 0. And if you keep playing with numbers, you'll see you keep getting closer to 0. And then because the limit as t went to negative infinity was a number, it was 0. That means we have a horizontal asymptote, and we have a horizontal asymptote at y equals 0. And this is a horizontal asymptote on the left side of the graph. I'm running out of space there. That says graph. So y equals 0 is a horizontal asymptote on the left side of our graph. So basically, I'm not really sure what happens in the middle of this function, but I know as we go off to the right, this function is heading up toward infinity. And as we head off toward the left side of this graph, this function is heading toward 0. Y equals 0 is a horizontal asymptote, so this is going to flatten out and get closer and closer and closer to y equals 0. So again, weird things could happen in the middle, but I know that this is what the ends of my graph look like. And I don't know what the middle looks like, but it doesn't matter because we're asking about asymptotes. All right, so this has one horizontal asymptote at y equals 0, and my function only approaches it on the left side of the graph. Okay, last one from 1950 to 1980. to 2010, the human population of the Earth has grown from 2.65 to 4.45 to 6.9 billion people. If T represents the time in years since 1950, okay, so T is the number of years since 1950, and P is the human population in billions, then we have this is called a logistic equation. That's just the format of this equation is a logistic function. Um, and so this function represents the human population. So P of T here is the human population in billions. And again, T here is the time in years. It's the number of years since 1950. And just this equation, the format of this guy is logistic. It's a number divided by an exponential. That's kind of what a logistic looks like. Okay, so I want to find the limit as x approaches infinity of this function and interpret this number. And again, it says x, but our x value is t. This should probably be t. Typo, sorry about that. So we're going to take the limit as t approaches infinity, as the number of years since 1950 gets bigger and bigger and bigger. What happens to this function representing human population? Okay, so we're going to take the limit as t approaches infinity of this function, 17.4 divided by 1 plus 5.56e to the negative 0.022t. Okay, this looks a little scary, but I'm taking the limit as t approaches 0. I only have one t in here, and it's right here. So what happens is this t gets bigger and bigger and bigger. Well, as t gets bigger and bigger and bigger, I'm going to have 17.4 divided by 1 plus 5.56 times e to the negative 0.022 times bigger and bigger and bigger and bigger numbers, which is going to push this to a huge negative number, right? Because this keeps getting bigger and bigger, which is going to push this whole thing bigger and bigger. And because this is negative, it's going to push the whole thing to negative infinity. Okay, so I have a negative and an exponent. Again, my brain doesn't like to do that, so let's rewrite that negative exponent as a fraction. So this is going to become 17.4 over 1 plus. This negative infinity exponent only applies to the e. It does not apply to the 5.56 because there's no parentheses. Without parentheses, the exponent applies only to the thing in front of it. So this is 5.56 times just e to that power. So the 5.56 is going to stay put, and that e to the negative infinity gets pushed over the division bar into a fraction. So that's what my negative exponent's going to do. Okay, so now what happens as I take 5.56 and I divide by e to bigger and bigger and bigger powers? Well, 2.718 to bigger and bigger and bigger powers gets bigger and bigger and bigger. What happens when you take 5.56 and you divide by bigger and bigger and bigger and bigger numbers? This thing heads towards 0. So that means this is going to become 17.4 divided by 1 plus 0, because this gets smaller and smaller and smaller. 17.4 divided by 1 is 17.4. That is the limit as t approaches 0. So that means that I have a horizontal asymptote at y equals 17.4, and it's only an asymptote on the right side of the graph. It's only on the right side. Again, it might be on the left side too. You can take the limit as t approaches negative infinity as well if you'd like. You'll actually find that it's a different asymptote. This is only an asymptote on the right. Um, okay, so what does this mean? Well, it means that on the right side of the graph, as I go further and further this way, my function is going to approach y equals 17.4. This is going to be a horizontal asymptote for me. And whatever my function looks like everywhere else, I'm not really sure what it looks like. I know that on the right side of my graph, this is going to be a horizontal asymptote, and I'm going to approach it. And so what do my y values represent in this function? Y values are P of t, and P represents the human population in billions. So as t, the number of years since 1950, gets bigger and bigger and bigger as time goes on, my y values, the human population in billions, approaches 17.4. That means as time goes on, the human population is going to approach 17.4 billion. And that's kind of where we're going to kind of level off and where the ceiling of our population is going to be, according to this model. Cool. So that answers this question. Um, and those were the last couple of problems. So I'm also going to send you these worked examples in case that's more helpful for you, but wanted you to have a video as well. So I hope that helped, and get working on section 2.7 because both 2.7 and 2.8 are due for you on Sunday, and then, or due on Thursday, sorry, Thursday, and then you have a test on Friday. So let me know if you have any questions. Otherwise, I'll see you tomorrow for section 2.8.